Hi everyone, today we want to talk about integration by parts and see several examples of applying this technique to compute integrals. Suppose we want to compute this integral. Well, if we apply ordinary methods of integration, you'll see that there's no easy way to compute this integral, but today we are going to learn how to do this. So the method to compute integrals like this, or a powerful technique of integration, is called integration by parts. And essentially, we use the multiplication rule for derivative, the so-called Leibniz rule, and derive an integration formula from that. So the integration by parts says that the integral of f prime of x, g of x, dx equals f of x times g of x minus the integral of f of x times g prime of x dx. You can also write this as the integral of u dv equals uv minus the integral of v du. Well, here u is g and dv is f prime dx, and v is f and du is g prime dx. So these are two standard ways of writing this formula. So before going to compute the integral of interest, the first integral, let's see a few easier examples. So let's start with this one. I'm going to take x to be u and the rest to be dv. So this implies that, this means that v prime is e to the x. So v is itself e to the x. And that's an easy antiderivative you can compute. So if we use this, we get uv, which is x e to the x, minus the integral of v du, which is e to the x. Du is just dx, because u is just x. Now we have a very simple integral, x e to the x. The integral of e to the x is e to the x plus a general constant of integration. Let's see another example. Now here, I'm going to take u to be x squared and dv to be the rest. This means that v prime is sine of x. So what is the integral of sine of x? That's just minus cosine. So v is minus cosine of x. So let's use this. So we get uv, which is x squared times minus cosine of x, minus the integral of v, which is minus cosine. So I'm going to change this minus to plus, minus cosine, du. Well, the derivative of x squared is 2x dx. So we get minus x squared cosine of x plus 2, the integral of x cosine of x dx. Now here we need to integrate by parts one more time. So this time I'm going to take u to be x and dv to be the rest, which means v prime is cosine of x, which means v is sine of x. So let's see where we go with this. So we get, well, we had minus x squared cosine of x plus twice. Now the integral of x cosine is uv, which is x sine of x, minus the integral of v, which is sine of x, du, which is just dx. Now the integral of sine is easy to compute. It's just minus cosine, so we get at the end minus x squared cosine of x plus 2x sine of x minus the integral of sine. It's minus cosine, so plus 2 cosine plus a general constant of integration. Okay, let's see another example. So here we have the integral of ln of a square root of x, and there's no other function. It's not multiplied by any function. Now in this type of examples, it's the other function is just going to be 1. So if I take this to be u, then v prime is 1, or dv is just dx, which means v is just x. So let's use this information. We get the integral of u dv is uv So it's x ln of the square root of x minus the integral of v du. What is du? Well, the derivative of ln of square root of x, that's the derivative of the square root of x, which is 1 over 2 square root of x, times the derivative of ln at square root of x dx. So this whole thing here is du, which is nothing but u prime dx. So let's simplify that. We get x ln of the square root of x minus the integral of, well, x cancels with those two square roots of x in the denominator, so we get half dx. We get, which is just x ln of the square root of x. The integral of half is just x over 2 plus a general constant of integration. Let's move to the first integral that we had in mind, the integral of arc sine of x squared. Again here, we take u to be arc sine of x squared and dv to be dx. So v is just x. Now what is du? Well, du is u prime dx, which is, well, the derivative of u is 2 arc sine of x times the derivative of arc sine of x, which is 1 over the square root of 1 minus x squared. So the integration by parts formula gives us, well, the integral of u dv is uv, which is x arc sine of x squared, minus the integral of v times du. So from du, I'm going to put 2 times 1 over square root of 1 minus x squared here, and the rest, which is arc sine of x, next to it. Now this last integral, well, we can compute this again using integration by parts. Again, I'm going to take u to be arc sine of x and dv to be the rest, or essentially v prime to be this function, 2x over square root of 1 minus x squared. So what is v? V is the integral of, well, v prime. So the integral of 2x over square root of 1 minus x squared dx. We can easily integrate this function using substitution. Let's take w to be 1 minus x squared. Then w prime is minus 2x. So let's multiply and divide by a minus sign here, and this is just w prime. So v is minus the integral of w to the minus half w prime dx, which is just dw. And this gives us, well, the integral of w to the minus half is w to the half times 2. We also had a minus sign. You don't need the constant of integration in this process because it's going to automatically cancel out. So we just need general constant of integration at the end. So don't use any at this step. So this is just minus 2 square root of w, which is 1 minus x squared. Now let's use this and compute the second integral. So we get, let's continue here, we get x arc sine of x squared minus, well, the integral of u dv is uv, so uv is minus 2 square root of 1 minus x squared times arc sine of x minus the integral of v du. Well, v is minus 2 square root of 1 minus x squared. I'm going to put the minus here and make this minus plus, times du. What is du? The derivative of u is, the derivative of arc sine is 1 over square root of 1 minus x squared dx. And you can see that these two cancel, and we just get the integral of 2, which is 2x. So we get x arc sine of x squared minus minus 2, that's plus 2 square root of 1 minus x squared arc sine of x minus the integral of 2, that's minus 2x, and we need a general constant of integration. So this is the antiderivative of the function arc sine of x squared. Now let's move to our last example, the integral of ln of x over x. I'm going to write this as the integral of ln of x times 1 over x dx. and I'm going to take u to be ln of x, and dv to be dx over x, or v prime is 1 over x, which means v is ln of x. So if we use this, we get the integral of u dv is uv, so ln of x times ln of x, minus the integral of v du. Well, v is ln of x. What is du? Well, du is just u prime at dx. What is u prime? U prime is the derivative of ln of x. Well, the derivative of the outer ln is 1 over whatever is inside it. So that's 1 over ln of x, and the derivative of the ln inside is 1 over x. So that's the integral of that's the derivative of u, and we get du here 1 over x over ln of x dx, and the two ln's cancel each other, and we are left with ln of x ln of x minus the integral of 1 over x dx, and that's an easy integral to compute. We get ln of x ln of x minus ln of x plus a general constant of integration. So that was our last example today, and I hope you enjoyed this video.